Current tool use agents often rely on large, monolithic language models. These models are expected to both reason about the problem and decide which tool to use, and then use it. This presents a scaling problem. Training and deploying these massive models is computationally expensive, and their performance can be limited by their ability to efficiently manage diverse tools and user preferences. Think of it like trying to build a single app that does everything. It becomes bloated, slow, and hard to maintain. The core idea behind ToolOrchestra is to decouple reasoning and tool selection from actual tool execution. Instead of a single massive model, we use a smaller, specialized language model, the orchestrator, to decide which model or tool to use and how to use it. The orchestrator model farms out the actual work to other specialized models and tools. This is analogous to a conductor leading an orchestra. The conductor doesn't play every instrument, but guides each musician to create a cohesive performance. ToolOrchestra employs reinforcement learning to train the orchestrator model. The agent observes the problem state, selects a tool or model to use, and receives a reward. Crucially, the reward function considers not just the outcome, correctness, but also efficiency, cost of tools used, and user preferences. This multi-objective reward function encourages the orchestrator to select the most cost-effective and user-aligned tool for each task. The orchestrator learns to predict the best sequence of tools or models to use to solve a problem by maximizing cumulative reward. The system takes a problem as input. The orchestrator model, typically a smaller LLM in this case, an 8B parameter model, analyzes the problem and selects a tool and associated parameters from a predefined set. This selection triggers a call to the chosen tool or model, which processes the input and returns a result. The orchestrator then receives this result, updates its internal state, and decides on the next step, either selecting another tool or generating the final answer. This iterative process continues until the problem is solved or a maximum number of steps is reached. The ToolOrchestra approach demonstrates significant performance gains and cost savings compared to existing methods. The 8B parameter orchestrator outperforms GPT-5 on the humanities last exam, TOEFL, and frames benchmarks while being considerably more efficient. Furthermore, ToolOrchestra effectively generalizes to unseen tools and shows robustness against self-enhancement bias. By releasing the ToolScale dataset, the authors aim to accelerate future research and tool use agent training. This research paves the way for more scalable, efficient, and user-aligned AI systems that can effectively leverage the power of diverse tools.